Hello everyone. In today's video we are going to see about lithium ion battery. So just like the other batteries only, we will have one anode, cathode, electrolyte and finally the EMF produced. So what is the difference between all these batteries is the type of anode, cathode and the electrolyte we are using. So only those three will differ and the complete mechanism will be same. So lithium ion battery is a secondary cell. That means it can be recharged and reused. Once the EMF which is produced by the battery is stopped or it is not able to produce the EMF, then we have to recharge it again, and after recharging it again we can reuse it, right? So in anode, in this lithium ion battery we will take anode as LiCoO2. That means lithium cobalt oxide. So we will use this as a anode in the lithium ion battery. So since it is a lithium ion battery, we will use all the compounds of the lithium only, okay? And at the cathode side we will use lithium doped graphite. So graphite is made up of carbon, as we know, but what we will do is, for this graphite rod we will dope with the lithium. Okay, why we have to do this doping technique is, we have discussed about this doping in previous videos. So whenever an element or whenever a substance is unable to transfer the ions, or whenever a element is unable to complete its exchange, so we will dope it with the other elements such that it will increase its capacity to exchange ions, and it will increase its capacity to make sure that it will produce EMF. So that technique is called doping technique, and here we will dope a graphite rod with the lithium. And as an electrolyte we will take lithium hexafluoride phosphate, okay, which is dissolved in the organic solvent such as dimethyl carbonate. So just as the other batteries, here also we will have one cathode end and one anode end. So this diagram I have just elaborated it just to make sure that what it will contain, but generally this is what the diagram is. So this is battery if you think, and this side you will have cathode and this side you will have anode, and in between this we will have electrolyte. So this is what electrolyte in this case, and we will have one separator just to make sure that anode and cathode will not be mixed, okay. So we will use this separator, and whenever we have we start using this battery, the exchange of ions will take place from one end to the other end, and what happens, we will produce EMF. So this separator will act as a membrane again here. So this will allow the exchange of ions. So whatever the separator we have used, it should be able to exchange ions. And here we will fill the battery with the electrolyte. Okay, this is what the working principle of the lithium ion battery. And now let's see the reactions of it. Okay, so at anode side we this is the reaction. Okay, Li, this is N is number of what do you say, number of lithium ions, how many are going to exchange, okay, number of lithium components, okay. And at cathode, this is the reaction. So overall cell reaction for discharging and charging. Charging means we are making sure that it is again able to work again. So in discharging phase, what we will use, that means we are using it, that means it is producing EMF. Here it is not producing EMF. In discharge phase it will produce EMF. Here it will charge to produce EMF in discharge phase, okay. And these are uses. We generally use this lithium ion battery for the portable electronics or electric vehicles, that means which are easy to carry from one place to the other place. So in such cases we will use the lithium ion battery, and most important example is we will use lithium ion battery in the mobile phones, okay. And then power tools such as cordless drills. So in all these cases we will use the lithium ion battery. Thank you.